finally you do the same thing, determine the rotation, the translation. And how do you determine the translation? You want to see if the wall is going to fall by sliding, and you already know that the value that is going to be causing the wall to fall have now increased because of the water, but the resistance of the wall remains the same. So if you divide this by this, you see that this will now be 0.64. Before it was more than this before. Now you see clearly that the wall is going to fall by sliding. You also check for rotation. And how do you check for rotation? Remember that we have already calculated this 1.29 from the last slide as where the resultant of the force is acting. So if you divide it by 4, which is the base, divide by 2 minus 1.29, you get 0.71. Then 0.71 is greater than b over 6. That means the wall is going to fall by rotation. We do the same thing we did in bearing capacity. Determine first of all, determine the vertical load coming to the soil as a result of the structure. Secondly, you will determine the bearing capacity of the soil, and this is the formula to determine this value will remain the same. You calculate this one, you remember that this one n here is equals to 2 because you have that we are considering this thing to be a strip footing. At the end of the day, you calculate the value of the bearing capacity of the soil, and the bearing capacity of the soil will now reduce because now we are using effective bearing capacity. So the unit weight will no longer be 20, but it will be 20 minus 2.98 because the water table have now risen from that ground where it is. It has risen to the level that it covers the structure. So it's now going to have 20 minus 9.8. From that, you multiply it by 2.58, which is the effective breadth of the wall, multiply it by the bearing capacity factors, and you have 14.65. If you divide 14.65 by 81, and this 81 is, okay, in this scenario, we are not just going to divide by 81, but we're supposed to divide this. This is a mistake, so you can correct it in your own work. We're supposed to divide it by 169.5. So when you divide, you see that the value we're going to have here is going to be much smaller. So you see that the wall is going to fail if the groundwater table rises above the wall and they cover the wall will be susceptible to collapse, susceptible to translation, susceptible to bearing capacity failure and rotation. And how are we going to remedy it? We're going to increase the sectional properties of the wall. That's increase the weight, increase the length, add the shear key to the wall so that it can be able to resist the sliding.